Buenas tardes. Welcome to all of you to this event, which will be mainly held in English, but allow me to speak in Spanish, since one of the priorities of the Fundación Ramón Areces is to foster the use of Spanish language in science. Queridos amigos y amigas, y sois muchísimos hoy, autoridades, colaboradores de Nobel Prize Outreach, señora secretaria de Estado de Digitalización e Inteligencia Artificial. Como soy el primero en hablar y nadie me presento yo solo. Soy Raimundo Pérez Hernández, director general de la Fundación Ramón Areces, en nombre de cuyo patronato y consejos científicos de ciencias sociales, hoy aquí representados, les doy la más afectuosa bienvenida a este evento que organizamos conjuntamente con Nobel Prize Outreach. Vaya mi agradecimiento en primer lugar para todos los asistentes que se han desplazado hoy a la sede de la Fundación Ramón Areces, en un día tan desapacible y lluvioso. Muchas gracias. También es mala suerte que no llueva nunca y tenga que llover justo hoy, pero en fin. Como muestra adicional de agradecimiento, me complace invitarles a una copa de vino español, o incluso dos, que se servirá después de este acto. En segundo lugar, quisiera agradecer la dedicación de todo el equipo de Nobel Prize Outreach, encabezado por Laura Sprechman y Adam Smith, con quienes hoy hemos tenido un gratísimo almuerzo. Gracias por lo grato que ha sido trabajar con vosotros y por vuestra profesionalidad y simpatía. Nos hemos convertido en buenos amigos desde que en 2019 coorganizamos el primer Nobel Prize Dialogue en Europa fuera de Suecia sobre el futuro del envejecimiento. Desde entonces algo hemos envejecido, pero bueno. Creo que fue un primer hito fundamental que generó una corriente de confianza y simpatía mutuas en nuestra colaboración con Nobel Prize Outreach, que espero y deseo continúe en los próximos años. Se ha convertido ya en un family affair o family business. También vaya mi agradecimiento al equipo de la Fundación Ramón Areces, que me consta ha preparado este evento con el máximo cariño e ilusión. Gracias, Manuel, Azcona, Vanessa, Álvaro, Pablo y todos los demás. Un agradecimiento, por supuesto, muy especial al profesor Morten Meldal, que nos honra hoy con su presencia. Otro gran agradecimiento al profesor Juan Luis Arsuaga, auténtica autoridad en su especialidad y bien conocido por sus reflexiones sobre la evolución humana. También mi agradecimiento a Erika Pastrana, wherever you are, destacada comunicadora científica, a quien nos llena de orgullo que ocupe un puesto de tanta relevancia en una de las revistas científicas, por no decir la más importante del mundo. Decía Pascal que lo último que uno sabe es por dónde empezar. Y voy a intentar empezar por el principio, lo cual ya es casi la mitad del camino. El seminario de hoy sigue al que ya organizamos el pasado 7 de julio sobre el tema Imagination at Work, que resultó un gran éxito y contribuyó a valorar a los científicos desde un lado más humano y personal. Este es, en efecto, el objetivo del programa de colaboración que mantiene la Fundación Ramón Areces con Nobel Prize Outreach, que se concreta en la edición de una serie de podcasts, cada uno de los cuales incluye una conversación con los premios Nobel del año anterior, sobre un tema determinado, pero enfocado siempre en aspectos concretos de la personalidad del científico entrevistado. El tema de hoy es Inspired by Nature y pretende valorar la influencia que el contacto con la naturaleza, el arte, la música o simplemente la belleza pueda tener en la vocación científica de una persona. Se trata, pues, de ver qué factores inciden en la inspiración y en la vocación de las personas que luego se dedican a la ciencia. Es, pues, un enfoque multidisciplinar que pretende ahondar en la motivación última y en la decisión de emprender una vocación científica. Para la Fundación Ramón Areces, el objetivo que pretendemos alcanzar en general es presentar a la sociedad española los avances y progresos científicos, realidad que intentamos alcanzar cada año. Pero en este caso se trata de hacerlos desde la transversalidad e intentar entender cómo, por qué y cuándo la crema innata del pensamiento científico contemporáneo ha decidido emprender su rumbo investigador. Los científicos son personas como los demás Y también influye en ellos, y mucho, el arte, la naturaleza, la música, que modelan su devenir. Al método y conocimiento objeto del proceder científico hay que añadir la inspiración e incluso a veces la casualidad, que tanto pueden llegar a influir. Pero esta reflexión va más allá y plantea cuestiones quizá más profundas, como son la delicada relación entre alma y cerebro o entre sentimiento y razón. A la ciencia se llega por muchos caminos. Estoy seguro que la personalidad del profesor Morten Meldal será muy inspiradora hoy y nos contará cómo llegó desde el contacto con la naturaleza a ser un destacadísimo científico en una disciplina que, reconozcámoslo, Abelino, es muy árida para un no especialista. El evento de hoy será moderado por Adam Smith, destacadísimo comunicador científico, experto en todas las ciencias, buen amigo y maestro como nadie en el manejo del idioma inglés. No por nada es inglés. Espero que disfruten del acto de hoy, que estoy seguro seguirán miles de personas que, como tantos de nosotros, participan de la creciente sensibilidad y renovado interés por la evolución de la ciencia en el mundo y especialmente en España. También saludo a nuestros seguidores de América Latina, que en números cada vez mayores siguen nuestros actos. A título de ejemplo, en el año 2022, el canal de YouTube de la Fundación Ramón Areces registró más de 5 millones de visualizaciones. Más de la mitad, el 53%, se realizaron desde Argentina, México, Brasil, Chile y Colombia, lo cual nos enorgullece y saludo a nuestros hermanos latinoamericanos. Termino citando a don Miguel de Unamuno, que decía que hasta una ruina puede ser una esperanza. En efecto, hasta la observación de un cúmulo de piedras puede crear una inspiración que trascienda la realidad. Y así es. Espero que disfruten de la conversación de hoy desde esa esperanza de la que hablaba Unamuno y que, como decía el clásico, es un riesgo que hay que correr. Muchas gracias. Tiene la palabra la CEO de Nobel Prize Outreach, Laura Sprechman.
Muchas gracias, Raimundo. Yo haré al revés, comienzo en español y continúo en inglés. A warm welcome to you all here present in Madrid and for all of you joining us here online. Dear Nobel Prize laureate Morten Meldal, querido Raimundo, dear speakers, Erika Pastrana and Juan Luis Arsuaga. I'm very pleased to open this session here today for our Nobel Prize Conversations. Inspired by nature, this topic connects with all of us. Nature is a source of inspiration. Nature is our home. It's us, and we need to protect it. Currently, 3/4 of our land and about 66% of our marine environments have been altered by us, humans. 1 million animal and plant species are now threatened by extinction. Yes, we do have an action plan on a global level, but we cannot afford to waste our time. We must implement all the measures by 2030. Nature is very close to my heart. My mother is a biologist, my father was a paleontologist, and from early childhood I learned to love nature, to enjoy it, to discover it, and not least, to respect it. Our brains are stimulated by nature, and we will probably hear more about that in a short while. As you return back home, or at some later point, I encourage you all to listen to our podcasts, Nobel Prize Conversations. We have a beautiful interview with Morten Meldal and with other distinguished laureates, and you will discover who they are, what interests them. It's a very nice companion to have while commuting or walking around. This is part of our public outreach initiatives that encourage knowledge-informed conversations about our big challenges that really that we're not lacking. And it inspires us to think, to connect, and to discuss, and hopefully to contribute to make this world a bit better every day. So on behalf of Nobel Prize Outreach, I would like to thank dear Raimundo, Vanessa, and all your fantastic colleagues at our dear Fundación Ramón Areces, friends, our Nobel International partners, 3M, ABB, Capgemini, EQT, H2 Green Steel, and Scania, and my dear colleagues led by Sandra Brandin and Adam Smith. Not least, of course, to all of you for joining us here this evening. I hope you enjoy the session y espero que todos aquí disfruten mucho. Muchísimas gracias, and now I hand over to my dear colleague, Adam Smith. Thank you.
Thank you very much, Lara. So, it's my very great pleasure to be your moderator for this evening, and I would like to add my welcome to those of Raimundo and Lara. And I'd like to start by thanking Raimundo and all at the Foundation for so warmly welcoming us again to this beautiful space, and also to thank Raimundo for organizing that it should rain this evening to make this particular Englishman feel at home. So thoughtful. The format for this evening is that, as with the podcast, the Nobel Prize Conversations podcast, I will begin with a conversation with Morten Meldal, who received the Nobel Prize in Chemistry last year. And we will talk for a while, and then we'll be joined on stage by our other panelists, Erika Pastrana and Juan Luis Arsuaga. And then we will have a conversation together, and I will make sure that there is time for you, the audience, to ask some questions and make some comments as well. So if I may invite Morten Meldal to join me on stage, please. Morten Meldal, welcome. Please.
Thank you to you. Thank you to Raimundo. Thank you to Laura for this honor. It's a great honor to be here. I'm looking forward to this discussion very much.
Thank you very much indeed. Well, I hugely enjoyed our previous discussion for the podcast. And of course, the title for this evening's session, Inspired by Nature, came from that conversation in a way, because I know that nature is very important to you. I think you were awarded last year's Nobel Prize in Chemistry for your invention of click chemistry. And basically, this is a reaction which happens with almost 100% efficiency under very mild conditions, very different from the sort of organic chemistry that you may have encountered at school, where you boil things up, or the conditions are very horrible. So you've invented basically the perfect chemical reaction.
Yes.
And I think that we all really want to know what it is about you that made it possible for you to dream of the possibility of this perfect reaction and also to spot it when it happened in your lab. What is it that makes you this sort of person?
Well, I've always been very interested, as you say, in nature in general, but also in just finding what can we do at the edge of where we are right now. So how do we come to the next step? And at that moment, we were using a process from nature called combinatorial chemistry, which requires you to make millions of compounds and then test them the same way that you do in nature when you are looking at the immune system or sexual replication. So this was where we took that process from. And in order to be able to do that, we had to have very efficient reactions. So we were scouting around for that kind of efficiency when I and my PhD student at that time, Christian Wenzel Tornø, we simply ran into this reaction more or less by serendipity. But we were very observant, and we completely changed the studies in order to investigate this particular reaction for the next year. And I think that's a very important issue if you are able to adapt and accommodate with the observations that you do in science. But to go back actually to the start of this inspiration by nature, as you're talking about, this comes all the way back from my childhood.
So let's talk a little bit, or let's have you talk a little bit about your relationship with nature when you were young. How did you encounter nature as a child?
Yeah, so I was very privileged because my parents took us around. We had 3 children, and we were dragged through nature, essentially, as children, to look at all the life there. And also my grandparents had a big farm where there were meadows and forests and beaches. We were able to run around and discover what the nature's like. And I remember clearly around 8 years or so, I was observing some field with barley, and there were some weeds and insects, big grasshoppers and beetles and butterflies and so on. And it was just so beautiful. And I was thinking, where does all this come from? Why does this exist so harmoniously? And from that time, I was really looking in particular for nature, where nature has been able to evolve by itself. And there you see absolute beauty. It's extremely beautiful. And whenever we as human beings intervene, you get monocultures, you get dying species, you get, we cannot paint the picture that the nature can paint, or the earth that we are living on can actually paint, in terms of how nature works.
I suppose many children are struck by that wonder with nature. I don't know if everybody is, but many are. And somehow, most children grow up to be, although they still enjoy nature, they lose perhaps some of that wonderment, or at least that curiosity to ask how it all came about.
Yeah, so my thought was, when I met chemistry at the first point, that chemistry is really interesting because chemistry is our way of explaining how molecules interact, our way of explaining why we get tired, why we feel pain, why we are in love, All of these things, emotions are controlled by chemistry, essentially. Of course, there's a lot of chaos in there as well, but chemistry is behind every single thing that happens around us. And in fact, everything around us is chemistry, except for some electromagnetic waves and things like that, which I'm not going to talk about tonight.
If there was a physicist sitting here, they'd be saying everything around us is physics,
Including the chemistry, and that's where we are now breaking down the barriers between physics and chemistry today.
Yeah.
So physics are more and more involved in chemistry and vice versa.
But listening to you talk about chemistry, of course, you make it sound so inviting. It's a wonder that everybody isn't intrigued by it.
Exactly. And I think that we have the completely wrong image of chemistry. Chemistry is not bad. Chemistry is here. And it's actually the reason behind life is possible because of chemistry, because the chemical components do what they do. And in my opinion, we have so many stars in the universe that life must be in many, many places out there, because it cannot not happen if the conditions are there. So I think that here we have a situation where we will never be able to contact any of that life, from my understanding of physics. But it is there, for sure.
That's something we might touch upon a little later. Yeah. Your introduction to nature also came through your mother. She was a painter, and she was very attached to nature, wasn't she?
Yes, she took all the elements from nature and also from Scandinavian old religion, the Valhalla kind of thing, and put that into paintings. And with a very strong relationship with nature, and she had a lot of understanding of also the human spirit and so on. So, yeah, she was a very good person.
And you yourself painted?
Yes, initially I did, but I haven't done that for quite a while. It's been more painting in the lab than on canvas.
It's a lovely parallel to draw.
And we do use actually computing very much for our molecules. So we are using virtual modeling of the molecules. And this is, of course, a three-dimensional world that we can use. And it helps us create this imagery of the chemistry that we can dive into visually.
When you say painting in the lab, elaborate on that statement.
Yeah, so that's, when you're painting, when you're a really good artist, you don't decide what you want to paint, and then you paint that motive. You go with the motive, and you let the motive develop your painting. And that is the same in the lab. So you make a reaction, doesn't work like you think it should. Maybe you observe something completely different, and you follow that. Or you think completely differently about that particular reaction, and next day you try something completely different, like other reagents, other conditions, other pressures, other temperatures. It's about being able to imagine how the molecule will behave under a variety of different conditions. And it's a wonderful thing when you fall asleep and you think about this problem that you couldn't solve today, and then the next day you go in, and because you had this consideration, you can actually solve that problem in the lab. It's a great pleasure to have that experience.
It's a sort of freedom.
And it's so organic chemistry is one of the few really creative sciences. That's why I always compare it to painting. Because you're making new molecules every time. Maybe they were never ever before in the universe, these molecules, because they are more small molecules with a molecular weight less than 1,000 than there are stars in the universe. So that's quite a lot.
We should just stop there and consider that point. That's extraordinary. So we'll never begin to make even a fraction of the possible molecules.
Exactly.
I love the idea of this free association that's happening when you're thinking about chemistry, that ideas are coming from right and left. It's not so structured, it seems to me.
No, there's a lot of gut feeling and intuition behind, particularly behind organic chemistry. But there's also a very strict understanding on how the functional group of the molecules actually behave and interact. So this combination allows you, this is like a very skilled painter like Monet. He can paint with few strokes from his brush. He can paint a complete bed of, what are they called, these things that cover the surface of the water?
Irises?
Yeah.
Lilies.
Yeah.
Lilies.
So he can do that with a few strokes from his brush.
Yeah.
And that's because he's very good at it.
So
the same with chemistry.
An underlying discipline, an underlying rigor.
Yeah.
And your painting you did for a while and haven't done since then, but music is something that you still do. You're still a musician. I imagine the approach to music is similar, that you have an ability, and then you free associate above that.
Yeah, that's the way it is, and it's a really great thing to do before you go to bed, because then you can release all the stress and all the thoughts of the day, and then you go and you're falling asleep while thinking on your chemistry or your music or whatever. But yes.
So again, listening to you, it seems to me that an important part of you is the freedom to...
I think freedom is essential to all human beings, and I think that we are seeing a clear example of this in the critical situation in Europe at the moment. How powerful the need for freedom it really is.
On an individual level, I mean, there are many levels to discuss freedom, but just on an individual creativity level, it seems that somehow, again, I mean, I know that there are many creative scientists, and I'm sorry to, just focus on you in your powers of creativity, but somehow you have achieved this freedom of thought, which, as I say, allows you to conceptualize things that others haven't been able to. In a way, everybody's been seeking reactions like click chemistry for a long time, but you found it.
And found is the right word. We discovered that reaction.
So there's, is it too much of a stretch to ask you what it is about your upbringing that left you with that freedom? Is that too difficult?
Yes, I think it's a balance between strictness and creativity, because my father was quite strict and my mother was a very caring person with a lot of creativity in her life. So I think this balance between strict and you have to perform, you have to get to the goal, and then my mother's creativity and intuition and so on.
So click chemistry was independently discovered by Barry Sharpless, with whom you were co-awarded the prize. You weren't working together, you both came up with it. Barry, the podcast with Barry Sharpless is yet to be released. It will come out in 3 weeks' time. As people will hear if they listen to that podcast, Barry Sharpless is quite a unique individual. He tends not to think in straight lines. He's always going off.
And that's the thing, the way it should be in science.
Exactly. But he is, to an extreme extent, no sentence completes itself. It always diverges. He himself would say he has an associative disorder. You seem to have a little bit of that kind of very pleasurable association disorder.
Very balanced.
Do you... I mean, it's obviously something that one would like to emulate, but I suppose it's...
But I think it's also playing into our nature as human beings, because we actually like to have this duality of something real and, chemistry, solid chemistry, solid law, if that is what we're doing, and then the contact with other human beings, which is more an emotional, creative thing that we have together, intuition. So most people like this balance between both and not just going for the goal,
So how do you teach people to become like that?
Yeah, so my opinion is that the world of chemistry is really a three-dimensional world. We have been teaching this as a two-dimensional world in many, many years. So everybody here is not a chemist. No, chemistry is sort of lines on a piece of paper. Doesn't tell you very much. But if you could actually see the image of this molecule as it's moving around, as it's interacting with other molecules and reacting and so on, I think you would have a completely different kind of understanding of the chemistry. The orbitals, which is where the electrons are, just pinch yourself here. What you're doing when you're pinching yourself here is that you're actually touching the electrons that surround the molecules in your finger. You are making a dent in the molecules. And this is actually how everything should be understood and seen, this three-dimensional structure of channels where electrons are interacting with the atom nucleus. Most of it is empty space. That's a fact. You are mostly empty space, all of you. And then there's the nuclei of the atoms, and then the electrons that form all the shapes around that. And this is what controls you. So the molecules interact with each other, fit like key and lock together, and give you a reaction. It can be, for example, in the immune system, which everybody knows. You have the antibodies. They recognize a ligand. They interact with this ligand through the electrons on the surface, and this is how we should learn chemistry. Also organic chemistry, how molecules react with each other. Where does the electrons go, and why do they do that?
You use a phrase, pleasure-driven learning.
Yes.
And again, listening to you, I can see where that comes from. That is the key, isn't it?
I think it is the key, because then you are addressing this urge for kids to actually see things visually, which today is really a danger because they have focused so much on the internet, where they get all these images in games of different kinds. I think we should try to replace those games with something much more useful, but in a pleasurable way that they will say, okay, this is really exciting. So, yeah.
And it comes back to the title again. They should be inspired by the nature around us.
Yes, very much so. And the understanding of how, for example, if we take this glass of water here, you can see this is a liquid. Shouldn't be a liquid. Should actually be a gas with the molecular weight that it has. But because the water molecules interact with each other in the way they do, they send electrons from one water molecule into the second water molecule through what we call hydrogen bonding. And this makes a three-dimensional network of a glue, so it sticks together. And that's why we have water. And water is really amazing. It's half of the recognition in your body is mediated by water. Yeah, so I think this is a very important substance.
Cheers to that idea. Okay, so hopefully the audience have got to know you a little bit.
Yes.
Understand you a little bit. You've perhaps turned some of them into chemists.
I don't know if that... I'll give you a lecture another day.
I think I would now like to invite Erika Pastrana and Juan Luis Arsuaga to join us on stage, please. Erika, do you want to sit here? So, Erika is the editorial director of Nature Research Journals, based in New York. And Juan Luis Arsuaga, as you all, I am sure, know, is professor of paleontology at Complutense and the leading expert on human evolution in Spain. So, let me start with you. Erika, you work for Nature Publishing Group. Inspired by Nature seems the title made for you. We've been talking a little bit about how you communicate scientific ideas to young people especially, but the public in general. Nature Publishing Group, as Raimondo said, is perhaps the top scientific publishing house, although others would want to argue, science, for instance. But you already have a captured community of scientists who use you, respect you, and want to be in your journals and read them. How do you extend that to reach out to the rest of the world who are interested and should be inspired by what is going on in your pages?
Yeah, thanks so much, Adam, for the opportunity and the great question. So I think there's two things I'd like to touch on, because I think there's definitely the public that's not a scientist that we try to engage with in our pages. And then there's the scientist who's a scientist in one discipline or that's used to communicating science in one's way, and how do we potentially improve that or change that? So first of all, I mean, we all experience a pandemic, still to this day, and it's very clear that, science is part of society, it's part of all of us, and that, the more we do to make sure we have a good understanding and a good communication of science, the better. Science is also not perfect. Scientists don't get things right all the time. In fact, we get things wrong most of the time, and then sometimes we get them right. And I think it's really important that the public, society, understands how the scientific process works, and that they can understand the scientific progress and evolution of science, and how some things are interpreted in one way and next day they're interpreted slightly different, and how our understanding of findings in the world changes. So we, as well as science and other platforms, use our opportunity to explain science to that public, to give science a recognition, but also to sort of give the scientific issues an opportunity to air and to be understood in society. So some of the things that we do in our editorials, for example, which are written by editors or journalists or our staff that want to surface an opinion. an issue that might be affecting science or society and that perhaps needs to be fixed or looked at or addressed. So these are opportunities. I think there is value in making science more understood. But I want to draw on something that Morten was saying earlier about how chemistry should be taught in a three-dimensional world, which I hope it's around the corner. I wish I had learned it like that. And that's how we think too as science publishers. I would hope before I retire, the way the science is communicating is not in a two-dimensional paper with figures that are stuck on a PDF and that one has to email somebody to get the data or the information that really sits behind the science that was done. I really dream that very soon, and this is something we think about, but others probably do too, we communicate science in a way that helps other scientists build on that work almost immediately. So wouldn't it be amazing if the moment that Morten, discovered the reaction, that it was possible for other chemists to directly play, download, redo his own analysis with their own hands, right, in the lab. So I think we need to all push science forward, and science communication hasn't changed in a long time. I don't think argue about that. So I think we as nature and others need to do better in improving also how we communicate science so that it becomes also more useful to the scientific society.
It's fascinating, and that's the approach you term open science.
Indeed.
Morten, do you want to respond?
Yeah, I think you're absolutely right that the possibilities we have today with the technologies that are available, if we give away a little bit of the rights and the profits in the business, we can actually reach very far with these technologies. So you instantly can download the crystal data from a crystal structure that was determined in Brazil the next day. That would be fantastic. It would go much faster with the development of the science in general. And I think that the whole field of science, including our funding schemes and so on, actually needs a revision.
Juan Luis, you are a much awarded science communicator. What would you say were your take-home messages about how you can inspire an audience to be interested in nature?
Do you remember the first sentence of the book, Peter Pan? It says, all children grow up, except one. That's Peter Pan. So this is the spirit. Because we scientists, we are a little bit. We have still the childish joy of exploring and discovering and living an adventurous life. And this is the spirit of science. So you have to communicate that joy, that appetite for knowledge, that spirit of taking life as a play, as a game, and enjoying living. This is science. Science is the joys of being alive, is the joys of discovering things, exploring.
Much more than that, actually, is also part of how we actually should educate our children. Yeah. So that it becomes common property. The understanding of science, particularly from a chemistry point of view, should become public property. So that if you are a mason or you are a baker or a blacksmith, whatever you do, you will be knowing what you are doing, and you will be able to make much better decisions in your life if you know science in more detail. So that it's not an exclusive community. The science community is not an exclusive community, but branch out in society in all directions. I think that would be really, really useful.
Yes.
And very beautiful too.
That's true.
But indeed, I love this idea of it being, if you like, slightly dangerous. It's exciting, and you're taking risks in science. You're out there.
It takes risks. It is is a little bit, always it is against the establishment, because you are not given the Nobel Prize for discovering something that is already known. It's by discovering something that is in conflict with transmitted knowledge. So the attitude of a scientist is rebel attitude. So you are criticizing, you are putting in question everything.
Yeah,
you are
rebellious.
not accepting nothing forever without being discussed and explored. So what we should transmit the young generations is that science is a way of is a way we inhabit the world. It's a way you live. It's the way you live, actually. So it's an attitude. It's a
I would say, though, that, I mean, I think we overemphasize in science the individual and the finding and the one sort of discovery and the one person that, you know, of course, and this is no comment to your brightness, Morten, but, you know, I think there is also a reality in science which is done little by little, and the minor contributions or the small contributions matter almost equally, right, to this, you know, aha moment that some scientists, you know, will be lucky enough to have. And that there is, you know, a whole enterprise, which is the scientific community, slowly moving towards, you know, these big findings. And that, you know, obviously it's this sentence about how you stand on the shoulders of giants, that, you know, when you're having that aha moment, you've been taken there through the collective work of a lot of people. So I think there's also an opportunity for us to teach children that, you know, you're not a failed scientist if you're not sort of going to have the Nobel Prize or have an amazing idea. That, you know, science is exciting even at the smaller scale. Even, you know, you have your own question and your own little sort of enigma to solve, and you go and do it, and that's fun, even if, you know, it's not this great thing that cures cancer or, you know, discovers a new reaction that is orthogonal to everything we know, things like that. So I think it's also important to make it more real. That, you know,
and also that's not why we are working on it. You know, we are not working on it to make this one unique thing. We are working on it to make something work, which we are looking forward to actually solve a problem. But we're not solving it because we want to be unique or have a prize or anything like that. Actually, I tell my students that if that's their goal, they should do something else, not science.
Yeah, you're working on it because you're inspired by nature.
Yes.
You're rebels having fun.
Well, if you ask the audience why do they read science news, for instance, in the newspapers, or why are they watching television when discovery is shown or whatever? The answer expresses it all. They watch that, or they pay attention to that for pleasure. So pleasure is the word. We do that for pleasure, because we like it. That's it.
Please.
And without pleasure, you can't learn. You can't learn because you are forced to learn. So it has to be because there's a will behind it. It comes from the inside that makes you actually think what you are reading, what you're studying, what you're looking at is interesting. If you don't have that drive, it's not science you should do. You should do something else. And I think that's why it's important to make it pleasurable, even in the schools, from first grade to learn science. It's very, very important.
Thank you.
I am a paleontologist, so it is maybe it's easier for me because I'm talking about wonderful things. Wonderful things. I can talk about mammoths. There were mammoths here where we are now. Not so long time ago. There were mammoths living here. And there were Neanderthal people living here where we are now talking, sitting. So it's wonderful. We have beautiful stories to tell. We are perfect storytellers. In the future, gold is a good story, because the more communication channels there are, the better for the storytellers. And among all the storytellers, we scientists have the best stories. I can talk about people can talk about stars, about the origin of the universe. People can talk about the oceans, the life there, ecosystems. Even the bacteria are wonderful. They communicate each other. It's wonderful. And we paleontologists, we have maybe the best stories.
So what I understand from Papo is that there's still Neanderthals even in this room.
In this room. No, that's even better. That's even better. We are the Neanderthals. We have a fraction of
Yes, yes.
So that's the perfect story. So, but I think that all science branches have wonderful stories. So I think that there is a future for science in society, not only for practical reasons, because science produces technology and it improves life quality of these things. But because the human brain, we know this from science. Human brain has an extraordinary appetite for stories. It consumes stories. Our brain consumes glucose and oxygen, not consumes, but uses oxygen, and mainly stories. So if you have a good story, you have a gold mine. And we scientists have wonderful stories. So I see a great future for science. I would like to stress and that the main point is not that this is useful for living day or daily life. It's useful for your brain because it will consume this with pleasure.
On the other hand, this is a mobile phone, contains about 30 Nobel Prizes, isn't that correct?
Yes, indeed.
So Nobel Prizes there's an idea behind it because it actually sets a trend in the chemistry that is carried out in the subsequent years, and or in the developments that are carried out in the subsequent years.
So, yes, and so, I mean, application and meeting challenges is part of it. You, Morten, were in part turned on to studying chemistry because of reading this book, Limits to Growth, which was published in 1972 by the Club of Rome, and basically said that humanity is going to hit a dead end when exploitation of resources, which is increasing exponentially, outstrips the availability of resources, which is at best increasing linearly. And this was a momentous thing for you, reading this book.
Yes, so the resources, and we know that is a problem because the large nations are actually fighting for the resources. And I think that the resources is one thing, but the other thing that was also clear was all the problems that we would hit with the environmental crisis was also part of that story, and I think that is really important today. We could have learned a lot 40 years ago, which could have prevented this, maybe set a different directions for the development, not necessarily a limit to the growth, but definitely a different direction at a much earlier stage, so we wouldn't have floodings in Pakistan or maybe desert here in Spain. Let's see what happens.
So this relationship between humanity and nature, humanity and the planet, Juan Luis, would you like to talk about that a little?
This is the history of humankind. This is what is more concerning, because if you look back to the beginning of the civilization in Mesopotamia, in Sumer, it is always the same story, it's cyclic. First, farmers started exploiting the natural resources of the area and building more and more complex civilizations and bigger cities. And they finally invented things like scripture, for instance, and these things. But they exhausted the natural resources of their region, so they expanded to other regions. They conquered other, and there was war, of course, but they conquered other regions that had natural resources still available. So they exhausted, after conquering new regions, they depleted completely the natural resources. But the civilization grew up, became bigger, more people living, bigger cities, more complex societies, religions, and so on. But the natural resources of that civilization, that happened everywhere. That civilization exhausted, depleted all the resources, and then they expanded into a new land. Finally, we completely exhausted all the natural resources in Europe, and then we went to America. And the cycle began again, and we started exhausting and exploiting natural resources in the new continent, in the new world, because the old world had already been completely depleted of natural resources. And finally, the last continent is Africa. And there is a conflict about natural resources in Africa. It is Africa, it is the ocean, it is Antarctica. The last natural resources for everything. And in the previous steps in this race towards the abyss, in previous steps there was always conflict, war, blood, and now if this trend were to continue, we should move to another planet.
We can't.
Start again.
Physically, we can't.
We cannot.
No, we cannot.
So we are trapped.
Yeah. So the answer to all of that is always technical development will take care of it. We'll find another way to grow crops. We'll find another way to purify the water. We will find another way to control the weather. And so, but all of these technological solutions can never cope with the complexity of nature. And that is a real problem in that view, that point of view, which is dominant in financial institutions and so on.
I mean, when you speak about this, Juan Luis, I'm always sort of asking myself how much of this is inevitable. I mean, we have been, growing at the expense of nature for such a long time. Yes. And obviously, when you think about it historically, at least, it all makes sense, right? Populations wanted to get bigger so that they can, have technological advances, more security of food, larger families, a more sort of comfortable life. And then, we're seeing this happen today, right? We're creating things like artificial intelligence that we know have huge risks to our society. And still, there's this big push that we really can't stop ourselves to do it because we feel like, technological innovation is what we were wired to achieve, almost like as a species. So, is this wrong? Is it that, we can change things? Or is it that, we followed a path that is pretty much the only path that was there for us?
I am afraid that in many answers to this problem is magical thinking. Something like some people, apparently, they are waiting a new miracle. And they say, well, science will fix this. Science will. We have a problem with energy, but science will fix it.
Before it was God who would fix it.
No, yes, but you cannot expect that things you have broken will be fixed all by a discovery that we solve all our problems, because maybe it will never be produced. A clean energy.
And this beauty of the nature, which is a very, very complex world. When we start to fix one place, something else appear over here, which is a damage, and we need new damage control here, new damage control, and so forth. This has happened so many times over the last 50 years that I think it's time that we really sit back and find out how can we let nature do the course that it needs to do. And it will eventually, so maybe without us, but it will.
Maybe without us, yeah.
Today we were talking, a group of scientists, about discovering someone that had discovered a method, developed a method to trap moisture, water in the atmosphere for deserts. It looks a very good idea because there is moisture. So if you can trap it, you can get it. So you can cultivate.
You know what?
But the idea, the wrong side of the idea is that it presumes that water, if you take water in one place, it doesn't affect the rest of the world or rest of the atmosphere. That, well, yes, it is wonderful to put water in this desert because nobody is affected by this, but there is people.
Exactly.
There are people.
So the water is, of course, evaporating faster and faster with increasing temperatures. So it goes up at equator, goes out, no water here. That's why we have Sahara. And then it falls down in Europe and south of Sahara in Africa. But the water really has to do this kind of convection. And if we take out the water here in the middle, in the desert, there will be no water out there.
So it's up to the scientists, you who do explore nature's secrets, to point out to everybody that science will not solve the problem. It's got to be a change of perception, an understanding of the interconnectedness of everything.
Yes.
A mixture of everything.
Yeah.
But science needs to be understood first. I mean,
Yes.
with the actions that need to happen for climate change, for example, until you really understand the problem, right? The cause and effect. So again, back to the beginning here of making sure everybody has a basic understanding of the problem, and it's not something that sits inside just the scientific community.
So I wanted to ask you, Erika, about that a little bit, because everybody understands that everything is interconnected and that the only solutions lie in a truly sort of interdisciplinary, interconnected understanding of things, not just science, but bringing in everything else that we know, humanities and social sciences and the whole lot. Publishers tend to segment things in order to sort of create markets, and they create chemistry journals and they create physics journals. How do those two things come together in your thinking?
Yeah, no, you're absolutely right. I think we all grew up in a world where science was very siloed. So you were a chemist, and then I was a biologist, and a paleontologist would probably not speak to a geneticist. And then how would we have known that we were Neanderthals, right? So I mean, it's absolutely essential that we break those barriers, and that scientists start talking to each other and speaking a language that everybody can understand, or at least. So this idea of sort of the multidisciplinarity of science is incredible, because if there is something to benefit from, is the geneticist talking to the paleontologist, right? Or it's the chemist talking to the biologist, so that really we do understand what the molecule is doing in the environment that is in. So, I mean, I don't think we're alone. The journals have evolved. I think over the years we've understood that there's other ways to make science communication more thematic. So, we talk now about a discipline which is sustainability. And sustainability can include things like social science and how we behave, and include things like chemistry or like energy. But, it's all those fields coming together. And, us physically, we actually bring a journal we create a journal to cover such a sustainability topic. We're hoping to bring the chemist and the social scientist together to speak to each other, to collaborate, to inspire each other, right? So I think, but we're not alone. I think universities are an excellent example. More and more universities have departments which are completely thematic and more sort of problem-focused than they are discipline-focused. So, we want to understand the brain. You will bring an engineer, you will bring a computational scientist, you will bring a physicist, and certainly a neuroscientist. But you're not going to build a department for neuroscience with only biologists anymore, because that would be a mistake, right?
Please.
I would like to stress this point because I feel that there is a great discovery that has passed unnoticed. The greatest of all discoveries has passed unnoticed. And the discovery is that all is interconnected. I will explain that. The idea of biosphere is only 1 century old, only 100 years old. It was developed by Bernatsky, a Russian chemist, by the way, in the 1920s. So before Bernatsky, the idea itself of biosphere was unknown. People didn't know that there were something like a film that is covering the planet, and it has a name, was given a name. But it was Bernatsky the first to use this term. Mm-hmm. So, and very recently we have discovered how this has been the last of the great discoveries in the history of science. That is the plate tectonics. How the Earth crust, the lithosphere, works. Mm-hmm. This discovery belongs to the second half of the last century. So we were alive when it was discovered. And this discovery has the importance of the Newton, Darwin, Galileo, the greatest discoveries in the history of science. So we have been so fortunate as to witness the last of the greatest discoveries, the Earth crust, how the planet works, the great synthesis of the geology, the plate tectonics. When I was a student, it was taught as just a theory, a possibility. Yeah, yes. It was not yet considered proved. But what I wanted to tell is that now we know that the planet system, that there is only one planet system that is made of different spheres, and that these spheres are all interconnected. One is, of course, the lithosphere, the Earth crust. The other one are the oceans, the hydrosphere. But there is also a cryosphere, the ice crust. And it expands a lot during the glaciations, but a lot. And it shrinks a lot in the interglacial periods. So it's not it's not that thin crust. It's 3-4 kilometers deep crust. So this is the cryosphere. And there is also the biosphere. There is also the atmosphere. And there is also another sphere now, that is the human sphere, the noosphere. That's a term that was coined by a paleontologist, French paleontologist, called Terra de Chardin. That's the last of the spheres. So what now we know is that if you take fossil fuels, for instance, from the lithosphere and put that in the atmosphere, it makes glaciers retreat in the cryosphere, and it makes that the hydrosphere, the oceans, rise 10 meters. So it is all connected. And we know now that what we do, the humans, in our sphere, the noosphere, produces changes, dramatic changes, in all the other spheres. So in the end, there is only one system, that it is the planet system. So this is a great, great, great discovery. Galileo was not conscious of that. Newton was not conscious of that. Darwin was not conscious of that. So nobody was conscious of that. And to me, it is the greatest or the final discovery in the history of science. And I would like that the audience were conscious of that. That has happened in the course of our lives.
It is a great discovery which should have profound ramifications
Of course.
for everything we do. Yes. Thank you. We should turn to the audience. I'm sure that people have questions and comments. There's somebody here. Could we give them a microphone? Yes, thank you all. Thank you. Could this person here, please? Oh, no, just here, please. Sorry. I'm sorry, just because I pointed to you first, you get the first crack, but I saw you as well. Yes, thank you. Thank you.
Good evening. My question is on beauty, one of those characteristics of nature that inspires her. And it used to be that beauty was a private hunting ground for poets, artists, and the occasional philosopher. But beauty increasingly appears or is mentioned in the context of science. It has been fundamental to the progress of modern physics, perhaps chemistry. I don't know, perhaps you could illustrate us on that. Beauty has a central role in evolution, as a development of symmetries and sexual attraction, etc. So my question is, do we have a good understanding of the relevance of beauty in nature and in the fabric of the universe? Is it mostly about mathematical symmetries?
You mean building in terms of construction? Or?
Do we have an understanding of beauty?
Of beauty?
From the scientific sense, yeah.
Okay, I have an opinion on that.
You can take that one, Morten.
Who?
Yeah, so we have evolved over, I don't know, but you probably know how long.
Nobody knows.
It's millions of years, 2.5 at least, I think, that we have evolved. And during all this time, we have been endowed with the images of the nature that we are in. There are some things that are threatening to us, and some things which are soothing to us. And I think that our understanding of this beauty and this connectivity and so on is based on our survival, ultimately. So we survive best in beautiful circumstances.
Does anybody else? Yes, please.
We have a sense. We are the only animals with a sense of beauty.
Yes.
No, that's more important than it looks.
We don't know.
Because we have the sense, we have the sight, we have the taste, we have different senses, but we also have, we humans, the sense of beauty. There was a big polemic between Darwin and Wallace, because Darwin invented sexual selection, that in many species, one sex choices makes choices about for reproduction based on that's the story of the peacock is the best example. So they look at the colorful feathers of the paradise birds and these things. So Darwin thought that the animals had a sense of aesthetics, of beauty. And Wallace said, no, it's impossible. Animals, they don't have a sense of beauty. And in the end, both were wrong and right at the same time, because Darwin was right in that there is such a thing as sexual selection, but Wallace was right in that the animals actually, they lack a sense of beauty, because they pay attention at the characteristics of their species, of each species. Each animal is sensitive to the what we could say call beauty of the partners of each species. But we humans, we can appreciate the beauty of the peacock, not being peacocks. Mm-hmm. And we can appreciate the beauty of the moon. And that's the thing that I have paid attention to. I try to know whether the chimpanzees, for instance, in a zoo, they can see the moon, but apparently they don't look at it. They are not impressed. They don't seem to have that sense of admiration.
But a banana.
The banana. They are more practical.
I think, although I think in Nature they just very recently published a study showing that chimpanzees do have this sort of declarative behavior where they show each other things just for the sake of showing them something without it having a use. So maybe they
for
do.
the beauty, or for practical, because
well, not for use, for something, for interest at least. and of course the beauty of an idea is
I designed an experiment. There is near Madrid there is a center for chimpanzees that collecting chimpanzees for recovery, so I wanted to make an experiment to put a chimpanzee one night of full moon to expose it to the full moon, and what happened? The experiment never was made, but in my view, well, maybe they admire it or they enjoy the full moon, but we are not able to appreciate it because we cannot understand their body language or something.
Yeah.
So it's not easy. But the question is, do animals, our nearest relatives, our closest relatives, do they become fascinated by a sunset?
So, I mean,
I would say no.
How would we know? An fMRI study on a chimpanzee with the full moon. Yes, I can see it now. Erika.
One thing that at least bothers me in the question, and I mean it in the best way. The challenge of the question is that we are a very social society as humans, right? We interact much more than other species do, and as such, have we agreed on our understanding of one beauty? Have we, made ourselves agree of a certain, thing like the moon being beautiful and something like a banana not being worth staring at, right, if we're not hungry? Have we collectively made ourselves all uniform in the sense of beauty? And could it be that it is not like that? That if you take us as individuals, as species, in an individual fashion, everybody would come up with a different sense of what is beautiful to them, what would they spend time admiring, what they wish to sort of, just spend minutes admiring. So perhaps we're asking the wrong question to the chimpanzees, and maybe they are, so scattered in how they enjoy their own individual beauty that, they don't have a unison, an agreed standard, right, like we do. I don't know. I don't know the answer, but I'm concerned that, while symmetry, for example, is something that some people have said is universal beauty, I would argue perhaps not. Did Picasso really find that beautiful?
My point is that, in shortly, that a peacock can appreciate the peacock look, and we humans too.
But I think there are two components to it. One is the learned component. Say you subscribe to a particular kind of art. Another one is the imprinted, DNA imprinted learning through human history. And I think there's a lot, we know how to do a lot of stuff. Insects do it instinctively. We have to think about it. But we know how to do a lot of stuff, and that is imprinted in our grown up, the way we grow up, but also very much in our DNA, I think. The good taste, the bad taste. How many in here have a scare of spiders?
Hands up if you have a fright of spiders.
One! Whoa.
Two! Oh, okay.
They're all scientists.
But Erika, the point you raise about uniformity of thinking is so important and so central to everything we've been discussing tonight from the very beginning of what Morten was saying and how he is able to come up with this idea. And there's much we can discuss about it. Perhaps we'll have the time to talk about AI and uniformity. Let's see. But we must come to another question. Thank you for that brilliant question. See what a debate it started. No, could we? Okay. Yeah, all right. You first, and then you, please.
Okay. So Professor Meldal briefly mentioned before the role of failure in science. And my question is, does nature fail? Is there a notion of failure in nature
Yes,
that we could be inspired by in the progress of science?
There's lots of failures in nature, and it's very efficient in correcting those failures. It's perform or die kind of experience in nature. And I think it's something that we will experience as well if we don't pay attention.
Okay, thank you, please.
So Professor Meldal, I'm a chemical engineer myself, but now I'm Secretary of State of Digitalization and Artificial Intelligence in the government of Spain. So I would like to make a question regarding the increasing role of artificial intelligence in scientific methods and discovery. And I'd like to make two questions. First of all, part of the scientific method is to create experiments and observational studies to gather data out of which we can make conclusions, causality, or discover new patterns that make us evolve as scientists. However, now, we don't need to perform new experiments because there's so much data available that we even call a new profession data scientist, while this scientist, not necessarily, has generated experiments to have a handful of that data. So do you see the word data scientist is the right way to call this new discipline? And second, probably the best scientific discovery in the recent years has been AlphaFold, which is an AI algorithm that has discovered how proteins are folded. Yeah. And even I think the Nobel Prize organization was considering if any time we could give the Nobel Prize to an algorithm or to AlphaFold. At the same time, generative AI is putting the challenge to discover that we are so far from artificial intelligence as human beings because the knowledge process and even the way, let's put, an AI thinks has nothing to do with how human brain works. And even in the pharmaceutical industry, they are discovering that, for example, for repurposing drugs, the strategies that generative AI is using is absolutely far from what human mind is proposing. So probably we can learn from artificial intelligence new strategies of thought that has nothing to do with the way humans think. So should be inspired by AI, apart from inspired by nation. So that are my two questions. The role of generative AI in scientific discovery, and if we can name scientists, those working with data, which have not designed experiments to get through.
So, artificial intelligence is just another computational method that we have to utilize. It's already happening. We cannot avoid it if we wanted to. It's gonna be explosive in this world, and we're gonna see fantastic results in data. You are mentioning one, which is the AlphaFold program, which can take crystal data from crystal databases of thousands and thousands and thousands of proteins, and it utilizes structural information in all these crystal structures, which is a three-dimensional structure of the fold of the protein chain, and then it can compare sequences with all these data, and it can do it extremely fast. So it's actively making first secondary structural elements and then packing those together into proteins. But it does not, and I stress that, it does not produce or reproduce the folding of the protein. It just creates a structure for us based on the information that we have given it. So all of these artificial intelligences are just using a large amount of data, filtering very efficiently towards a particular result. And the chat AIs are really important today. They can produce code, so if you ask it to do a program for you, it will produce a code. This is just in the beginning of it, and I think there's a danger in having AI that is able to produce its own code. So I think that we should really look out for that. The other thing is, when do we really know how to make a computational consciousness? Because that is the second thing you need for a real AI to work. And it's going to happen probably because you want AI to be decisive in the case where it's used, for example, for defense purposes. And you cannot have a decision without a consciousness of some sort, not a human consciousness, but some sort of realizing I am here to do this. And these kind of very fast decisions are kind of dangerous in my mind. But it's going to be a great, fantastic help in sorting out all the data that are now available due to all the publications that have been made over the years. It's very difficult to actually handle all that information today for a scientist. We have fantastic softwares to do that, but it's still growing exponentially. It's very difficult to have all of it encountered in your work.
Do you think it will be able to make the sort of creative associations that are so key to scientific progress?
I don't know. And I won't say it. You don't get me to say that it won't, because I have no idea whether it's going to happen. I mean, you can get an AI to come up with combinations that you would not do as a human being. So is that novelty or not?
That's a good question. Yeah.
I think that the crucial point is whether, for us at least, whether artificial intelligence, if we are going to lose our jobs. I mean, as scientists. What I mean is whether artificial intelligence will be clever than us. The question is, can artificial intelligence do our job better than us? If that were true, it wouldn't be a bad notice for society. For instance, presently we are unable to find a cure for diseases as cancer or Alzheimer and things like that. It would be nice that artificial intelligence would make that job for us. We could ask artificial intelligence, please, tell us how to cure Alzheimer, and we will have an answer. And that will be the solution of all of our problems. We will ask artificial intelligence, please tell us a source of clean energy. Artificial intelligence will do it for us. So, since none of us believe that we are going to lose our jobs because artificial intelligence is going to find the cure for the diseases we are worried about. We don't think that. We don't think that they are going to publish papers in Nature.
So yes, I mean the extent. To put it straightforwardly, do we think that artificial intelligence will be sitting here in Morten's place in a number of years' time?
So I was going to ask exactly that question, and my own answer is that not the artificial intelligence we have right now. I mean, back to your beginnings and how you described click chemistry and the discovery of the reaction as a serendipity issue. You were asking a question that probably wasn't unique to you. Many other chemistries labs in the world were asking that question. But would asking a machine or asking right now artificial intelligence what could be a reaction that proceeds without any heat or interference of biological systems or you name it, and give you that solution? I think not. I think what we have right now is algorithms that can process incredible amounts of data and make very good statistical inferences from that data to give you the most probable answer. And if you're looking for a probable answer, then yes. But what we're looking in science oftentimes is a creative answer, is something that happens almost by accident and that somebody is there to see it and to then sort of follow up on it.
Unexpectedly.
So I do think what we have now is called artificial intelligence, and I think that is a very lofty name for what we have. However, I do think that processing incredible amounts of data is something we couldn't do and humans could never do. So there's definitely something augmented about having this capacity for scientists, for everybody, in their jobs, in that we are going to do our jobs very differently. And we are all going to become data scientists in some way. And I'm hoping all the kids are learning data science in schools, now, because not having that capacity to augment your job with AI is going to be a handicap.
But my point, let's imagine that artificial intelligence sent a paper to Nature.
They already have. We've gotten flooded with papers written
I have discovered the solution for the Fermat theorem, for instance. And sending the Fermat theorem, I have found the solution. The artificial intelligence could solve all the mathematical problems that we are unable to solve so far. So if that time happened once, that would be a real change, that they would send papers, something like that, papers to Nature with new discoveries, with new theories, with new explanations. But this is not something that we expect is going to happen. That's my view.
Let's change topic again. Yes, please. Who has a microphone? Yeah. You do. Good.
Me, myself. Well, first of all, thank you very much for your really inspiring conversation. So my question is mostly for Erika, but it's for all of you. So you spoke about universities and how, for example, for neuroscience department...
Can you do like this?
Oh, that's me.
Okay.
You said that, for example, for a neuroscience department, you wouldn't have just a biologist, you would have a computer scientist, which myself, so a biologist and whatever. And my question is, that is for research, which is very good, but does it make sense to have such a wide variety of different degrees instead of having, like in the past, we could just have like tritium and quadrivitium or something like it, which was just like sciences and social sciences. So does it make us better scientists to have it separated, or does it make us better scientists to be like whole?
Yeah. Erika, go first.
Great question. I mean, personally, I would say it makes us better everything to have a variety of interests, because then you're cross-pollinating yourself in your own brain, your different interests, right? So Morten was a painter, and then he became interested in chemistry, and very likely the two things collide in his brain in some way that he can see molecules in a way that other people can't. So I think, however we cultivate that diversity of interest, absolutely. The more the merrier, and the more different that they are, perhaps the more complementary that they'll be someday, right, in your own brain. But whether education from the beginning, from school, has to be that way. I'm not an expert in education, but I would think that it is very good to enrich and to cross-pollinate as much as possible. And certainly in the sciences now, I would hope that the way biology is taught is very different to the way I learned it, downtown in La Autónoma a few years ago, because, we were very siloed and we never heard about computer science and other things that would have been phenomenal to know about.
But Erika, just as Morten was saying earlier, there has to be a certain rigor on which to build the ability to associate. Yeah. So you can't, once upon a time, maybe you could learn everything, but whether you can now, sorry, Morten?
Yeah, I think that's, of course, multidisciplinarity has shown its power. It's a very strong thing. But there are two fundamental sciences, which is physics and chemistry, which is about what we have around us and how it interacts. Then you have a lot of derivatives, like nanosciences, derivative, physics and chemistry, biology, derivative of mainly chemistry, medicinal chemistry, right? So you have a lot of different areas, but all of them are based on the two fundamental sciences. And I think we forget that once in a while, that there are these fundamental processes and our molecules that work in the way they do. And this we need to understand before we can understand how life works, before we can understand how catalysis is, before we can understand, just making materials. This material here on the floor, what is that made of, and how did we do that?
Thank you. One more question maybe before we break. Okay, sorry, just there, because yes, thank you. And
Hola, buenas tardes. La pregunta es la siguiente. Primero que nada, a medida que el humano aumenta su longevidad, queda a la vista que tenemos una obsolescencia programada a nivel individual. Es decir, cuando falla el cristalino, aparecen las cataratas, hay que operar la vista, si es que no falla la próstata antes, ¿no? Más allá de esa obsolescencia individual, quería referirme a lo que podría ser una obsolescencia colectiva. El ejemplo es el siguiente. Cuando hablamos del principio de Peter, dice que un individuo crece en una organización hasta alcanzar sus niveles de incompetencia. Y la duda es la siguiente, con esta situación geopolítica, este nuevo desorden geopolítico y esta cantidad de cambios que nunca la especie humana había tenido tan seguidos y tan versátiles, no estaremos alcanzando de alguna forma unos niveles de incompetencia operativa. Es decir, en vez de cambiar de planeta, ¿no deberíamos cambiar nosotros? Gracias.
Seguramente que sí.
So I think everyone should have a crack at that. Morten, do you want to go? Are humans reaching a point of obsolescence?
Well, we definitely are reaching in many places in this world incapacity, political incapacity, and also I think you have different types of structures in the world that controls everything, and here we have democracy. And democracy has a problem that every 4 years you need to elect your politicians. So even if you had solutions to the problems, maybe because we as individuals are electing the politicians based on our need for whatever, not paying taxes the next 4 years, that's actually creating a problem in taking the long-term decisions in democracies. In autocracies, you have a different kind of problem, and that is the lack of capacity of the leaders, because they don't have negotiations and about the decisions. They're just making decisions wildly without really considering long-term problems for us human beings. So I think we are at a stage where we have difficulties as a society today, and it's more and more obvious with the polarization of the world.
Eric, I'll come to you last. Erika first.
I mean, I agree with you. It looks pretty bleak, but I would argue that if you look back in history, there have been horrendous moments before us, right? I mean, if you think of any example, our history in Spain, but certainly in the US or other parts of the world. So I don't know. I mean, I think we, humanity, have been at this for a long time, being sort of really a terrible species to ourselves, right? To our brothers and sisters, human rights. I mean, there has been so many moments in time where we've made, the worst out of our opportunities. So I kind of tend to think, just to give it a positive flip, if possible, that, we do create challenges for ourselves as a society and then find a way to come out of there and find another bigger challenge, around the corner. So I don't think that we're in such a unique place, would be my answer. We've been here before, unfortunately.
Thank you, Erika. Juan Luis, as expert in human evolution, have we reached our sell-by date?
No. There is no such a thing as a programmed senescence. Senescence is not, it happens, but it's not programmed. And there is no such a thing as a species senescence, programmed senescence. But I would like to say that I used to be pessimistic, but until I read Karl Popper I read Karl Popper in a book that was a conversation with Konrad Lorenz. Karl Popper had good reasons to be pessimistic, very good reasons. But he wrote, it is mandatory to be optimistic because pessimist people do nothing. They maintain the status quo. They change nothing. You must force yourself every day to be optimistic, because only if you are optimistic, you think that things can change. And he wrote, Karl Popper said, we have no right to tell our children that they are born in a horrible world when there are so many people that could be helped and deserved to be helped. So we cannot afford being pessimistic. We have to impose ourselves the obligation of being optimistic. This is what I think.
I cannot tell you what a joy it is as a moderator to have a panelist who finishes things so beautifully. There is really nothing more to say. But nevertheless, I shall say thank you. I shall thank you all for being here this evening and giving us your time and your questions and your attention. Thank you very much indeed.
And thank you for the excellent questions.
It was a pleasure working with everybody. Thank you.